work on pages 1 and 2, 4.8, solving right triangles. So we're going to try to find all the missing angles and all the missing sides. Make sure you note that when we see the capital letters, we're referring to the angles. So if we see big A versus if we see lowercase letters like little a, we're talking about the measures of the side lengths. So moving on, let's look at this first one. So for this first problem, they give us little a and little c. So I'm going to write over here that little a and little c were given. And then we have to find the rest, big A, big B, big C, and little b. So since I'm given two sides, I'm first going to find little b, right? That's across from big B. We know that little c is across from big C, and we know that little a is across from big A. So let's find little b. We'll do Pythagorean theorem. So we're going to do a squared, 10.2 squared, plus b squared is equal to 20.4 squared. When we solve, we're going to end up getting 17.67 for this side. So I'm going to write PT, meaning we found this using the Pythagorean theorem. Next, we're going to try to find the angles. So we're going to think about SOHCAHTOA, and because they tell us that it's a right triangle, we also know that our angles go in order from smallest to largest, right? So we're going to think about a few of those things. Let me scroll down. We know that if out of 10.2, 17.67, and 20.4, the biggest side corresponds with the right angle, right? So we know that C is 90 degrees, and we know that that longest value would be the hypotenuse, right? So from there, we're going to try to find angle A and angle B. It doesn't matter what you try to find first. I'm going to pick angle A. Now, if I'm going to work on picking angle A, I need to figure out what part of SOHCAHTOA do I maybe need to use. Let me label in reference to angle A, which I'm going to call theta. This side would be the opposite. This side would be the adjacent. And this side would be the hypotenuse. Now, if I want to find angle A, let me decide what part of SOHCAHTOA I want to use. So let's write sine of theta. Now we know that sine is opposite of hypotenuse. So we'll do opposite of the angle is 10.2. Hypotenuse is 20.4. So if I'm going to work with sine to find theta, angle A, I know sine is opposite of the angle over hypotenuse. So 10.2 over 20.4. And now we'll do inverse sine of that value. And when we do that, we're going to get theta for angle A is 30 degrees. So that's how we find that. We knew that because it was across from the largest side length. We labeled the triangle and used sine theta to find A, right? And once we do that, whatever's left, we only have one angle left, right? We can subtract the other two from 180. So we know that all three add to 180. So 180 minus 30 minus 90 will get us the 60 degrees. So we do 180 minus the others to get your last angle. Okay, let's move on. So notice for the next one, we already have the answers. Notice that we don't have 30, 60, 90. So don't always assume that it's 30, 60, 90. Let's label first what they give us. So what they give us is angle A is 61.7 degrees. They give us angle C is 90. And they tell us that little c is 106.2. Remember, across from big C is little c, across from big A is little a, across from big B is little b. Now I'm first going to search. So let's first write given. What else were we given? We were given this. We were given little c. So let's pick what we want to find next. I think it's easiest to find the third angle since we already know two of them. So I'm going to do 180 minus 90 minus 61.7, and that's how we get our 28.3. So it's 180 minus the others. And it's not always B. If you had C and B, you would do for A, 180 minus the others. Okay, so let's pretend we need to find little a and little b. Let's label this first as 28.3 degrees. So I'm going to pretend that I want to find little b first. If I decide to work with angle A, I'm going to call that theta. I'm going to label this as the opposite, then little b would be the adjacent, then this is the hypotenuse. Now, if I want B, the only side that I have currently is this side. So out of SOHCAHTOA, I want the B, which means the adjacent. So I want the adjacent. So right off the bat, I'm going to cross off sign. And I have the hypotenuse. So I have the hypotenuse. Over here, I don't have the opposite, so I couldn't use that one. So we use cosine. So cosine of the angle we circled, cosine of 61.7 is equal to adjacent over hypotenuse. So adjacent is B, hypotenuse is 106.2. So then from there, we can multiply both sides by 106.2. Cancels. So the cosine of 61.7 degrees times 106.2 is going to get us 50.34. And then to find our last side, to find A, now that we have two sides, we can use Pythagorean theorem. That's just one way of doing it. So to find A, if it's our last side, we could do, if we know that this is 50.34, we could do 50.34 squared plus A squared is equal to 106.2 squared. And then when we solve for A, we get 93.51. Or another option, if you were working with SOHCAHTOA, and if you wanted, in reference to angle A, if you wanted the adjacent, if you want this, and you could pick either value that you have. Let's say you had, if you want the opposite, you have to use this or this, so we can't use this. And if we have the adjacent, so if we have the adjacent, we could go with tan. But we could also go with sine because we know the hypotenuse. So you could say tan of the angle that you're working with is its opposite over its adjacent, 50.34, and multiply both sides by 50.34, and you would get the value of A, and you would still get 93.51. So two different ways of doing it. Once you have two sides, a lot of people like working with the Pythagorean theorem. So let's look at the second page. So we're just doing these two pages today. So angle of elevation is when you look up, okay? Angle of depression is when you look down. So angle of elevation is usually something's on the ground or low, and you want to do a line of sight, and then angle of elevation as you swing up. Then we're going to draw a right triangle. So this theta is our angle of elevation. When I'm looking down, when I'm somewhere up high, I do my line of sight, and then I'm going to do swing down, and stop wherever you want. Doesn't need to be drawn to scale, as long as it's not too big. Create a right triangle. So this angle in here would be our angle of depression. So this theta, angle of depression, this angle theta would be my angle of elevation. So for example 1, it says to measure the height of a cloud, a vertical beam of light is directed on a spot of a cloud from a point 135 away from the light source. The angle of elevation to the spot is found 67.35. Find the height of the cloud. Okay, so you know the cloud is up in the sky. You know that there's some kind of light source. You know that if the light source is beaming up, if you draw a straight and then swing up to create that beam, you have that line. The angle of elevation is 67.35. Then it says the distance from the point 135 feet away from the light source. So that's how we know that this distance is 135. And then it says find the height of the cloud. So the height of the cloud, you can label this as a variable unknown. We can just say x is the straight up and down to the ground, and then you'll form the right angle there. So for this then, you decide what part of SOHCAHTOA you want to use, right? You can't use Pythagorean theorem because you only know one side length. So if I'm going to use this angle, I'm going to label this as my opposite. I'm going to label this as my adjacent, and this is the hypotenuse, right? So what we want is the opposite. So if we want the O, we need to also pick something that we have. We have the A. We have an A, adjacent. So if we want O, we want to go with either this one or this one. So we're not going to go with that if we want O. If we have an adjacent, we're going to need to go with tan for this problem right now. So we're going to say the tan of the angle we're referring to, 67.35, is equal to the opposite of that angle, which is x, over its adjacent, 135. To solve that problem, we then are going to multiply both sides by 135. So then x is 135 times the tan of 67.35. So over here, it's the same thing. It's just written twice. Just make sure your mode is in degrees, since they gave us our angle in degrees. And our distance we say is feet because they talk about feet. So 323.52 feet. Okay, let's look at the next part. Now the next one's a little bit tricky. Try to scoot down.